that down. So, gentlemen, we went through and we condensed our left side, then one log rewrite, we rewrote it and expanded by FOILing, factored, and we rejected anything that gave us a negative. I really like this website. And I probably should have put it up before. Hopefully it'll come up early. It's duty. It's a duty site. Here's our dutyfree.com. If you get a chance, you want to explore this at some point. You can see that this is our unit circle. And you can see how we've got degrees and we've got radians, and then we've got the sine and cosine values all the way around the unit circle. And what's really cool about this is you can take the triangles away. You can take your degrees away. You can take your radians away and just leave your coordinates or vice versa. I think that's kind of cool. I want to throw degrees in for a minute. And really what I want to be looking at is I want to look at quadrants 1 and quadrants 4. And we know that if we have a 30-degree triangle, what's 330? Same as what? A 30-degree triangle is the same as what for 330? It would be the reference angle, but if we start this way, what's this going to be? Negative 30. So that's something that I'm going to be looking at. So we've got 30, and then if we negate it, we're going to come down here to negative 30. Now, why are you telling us that? I want to look at some angle identities. Angle identities, and specifically negative angle identities. So let's say we have, here's theta right here. We're in the first quadrant. We know all students take calculus. Sine is positive in quadrants 1 and 2. Now, if we want to take the sine of a negative angle, so right now, here's our positive angle. Here's my negative theta. What's sine going to be? Negative. That's all. So sine of negative theta is just going to be negative sine theta. Let's take a look at cosine theta. Here's cosine theta, same position. But now we negate and do a negative angle. What's cosine down here? Positive. So what's going to be under the green box? Cosine theta. Yep, just cosine theta. What do you think tan is going to be? Negative tan theta, because tan in the fourth quadrant is negative. So basically all it's just saying is, okay, if we use a negative angle instead of a positive angle, what's our sign going to be? That's it. So those are negative angle identities. I don't think you need to memorize them because I think they're easy enough for you to go through. Reciprocals are going to be the same. So anything for cosecant, for secant, and for cotangent, same scenario. So then, what are some examples? These are some questions that came from Regents exams. Tan theta is 3.1. Well, what would negative tan and negative theta be? Negative 3.1. That's it. It seems pretty easy. It is. I've seen, these are the only two questions that have been on the Regents exams before, because they're a little too easy. How about cosine theta? Negative 0.25. What about the negative angle?
0.25. Positive.
What do you think? Think about, we did cosine. Cosine theta. When we did cosine of negative theta, it was a positive version, right? Wouldn't it just be the same exact thing? We're not negating the answer. We're keeping the answer. So it's negative 2.5. Oh, negative 0.25. The other answers change because it's the negated version. Cosine stays exactly the same. It's the only thing that doesn't change signs. So the answer still is negative 0.25. Are you clear with that? Yes, no? Possibly. It's the only one that the sign doesn't change. All right. Let me hand out my geometry notes. Remember earlier I told you, so in the geometry notes, I want you to take a look. Back in the day before calculators, that's like my time, we had tables of values that we had to utilize. We couldn't use the calculators. So we had to actually look up tables of values, and they would give us tables of values on the Regents exam. So I want you to look at these table of values. When a cosine value and a sine value are the same, their sum is 90 degrees. So remember I told you I kind of have color coordinated up here? She went to the red maybe and looked at the red value and looked at this red value. They're the same. Then she looked at this. This is 85. This is 5. 85 plus 5 is what? 90. Then she went down here. Okay, 33. I have purple box, and at 57 I have a purple box. They're the same value, and they add up to what? 90. Same with the yellows. Same with the 45 and 45. So when the value, the trig value is the same, the sum is what? 90. That's huge. So look on your paper here. And they gave you that anyways. What's really important is this is the first cofunction you're going to learn. It was the only cofunction that the geometry students learned. This, is it on your paper? Oh, it's not. I gave you guys a different one. That's okay. And even better for finding it. Nice job. This says sine theta equals cosine 90 minus theta. This is the first cofunction you're going to learn. You guys are in trig, you have to learn more. Think about why this works. Danny, do you remember when we first graphed sine and cosine, and you said cosine was the same as sine, just translate it 90 degrees? Shift it, just shift it left and right. Thus, there's the reason why. Now, the big thing here is with your cofunctions, sines on the left, cosines on the right. So think about this. If we have cosine of 85, what's sine going to be? If we have cosine 85, what's sine going to be? 5. Because 85 plus 5 gives you 90. If I have cosine of 30, what's sine going to be? 60. So if I find cosine of 30, you help me. Cosine of 30, does it give it to me? Yes. Where's cosine 30? Is it on this sheet or no? No, let's do cosine 50. So I've got cosine 50. What should sine be? Cosine's 50. Yep, let's look for sine 40. Are they the same values? 0.61, is it 29? I can't read it up here. Is it 0.6129? They're the same exact values. Same exact values. Now, why is that the case? Look at these, and you can look at this. I don't know if you do kind of have it off to the side. Think about this. If you want to find the sine of theta, and let's do it based on 67 degrees. So let's do sine of 67 degrees. Sine is opposite over hypotenuse. X over 7. Sorry, X over 0. What's 67 plus 90? 67 plus 90? 157 subtracted from 180? 23. Let's find cosine 23 degrees. Cosine is adjacent over hypotenuse, x over z. What do you notice about the ratios? They're exactly the same. Thus, that's why we have these cofunctions. So it works with sine and cosine, but it also works with additional trig functions. And that's where we're going to go. So now, we talked about this in my own method with the other class. If this is 90 degrees, you know that these two have to add up to what?
180. That's
90. These two have to be complementary. Because Diego, all the angles of a triangle add up to
180.
180. So we know that those two sum to 90. That's where the 90 comes into play. Sine theta in this one is what? Using that triangle as value for sine theta.
For which angle?
Theta. Find sine theta.
3 over 5.
Thanks. And what's cosine omega? This is omega.
3 over 5.
3 over 5. So then we say that these are cofunctions because they have the same trig value. So because the sine theta's value is equal to cosine omega's value, so then we can work it so that we have this cofunction. Remember, I said I like sine on the left, cosine on the right. It can be switched around. But you know that the two angles have to sum to 90. They have to sum to 90. That's your first set of cofunctions. You've got 4 more. And you've got to memorize it because they're not on your formula sheets. But the nice part is they're pretty easy to memorize. Sine and cosine go hand in hand. So look what we've got here. Sine theta equals cosine 90 minus. It's always 90 minus, 90 minus. So sine and cosine are cofunctions, cosine and sine. You can switch them around. Tan and cotan, cotan and tan. Secant, cosecant, cosecant, secant. They've got to be committed to memory. Everything though is 90 minus theta. But you can see these are just reciprocal functions. And these are just sine and cosine reciprocal functions. Co-functions. How you guys doing back there? Need a little help?
We're just not.
Okay. They're gonna. I'll be back there. Help you in a minute. So let's get some examples down so you guys know what you're going to do with this stuff. Do you have these copied yet?
Yes.
Almost. That's what it is. You're taking on all of that. You can't do. All right. Here we go. All right. So how are we going to do this? For which value of theta is this going to be true? You try to answer this question, and then I'll show you how to do it if you don't get it done. Find a value of theta for which sine theta equals cosine 15 degrees is true.
Wouldn't just be 90 minus 15.
Mm-hmm. So what do you think your answer is? 60.
60.
So I think it should be 75 because you just want theta and 15 to add up to 90. So how do you check yourself? Okay, well, take your hands in and calculate. And check your mode. You're in degree. We just said sine 75 should equal cosine, what was it, 15? I did the same? Then you're right. That's how you check yourself. This has been a 2-point question on the Regents exam. Sometimes it's multiple choice, sometimes it's short response. It's awkward because it's kind of new for the Trig exam, and it doesn't really even tell you anything. It just says find a value that makes it true. How about this one? I want you to write the expression for tangent of 265 degrees as the function of an acute angle whose measure is less than 45. So that's the first thing I want you to do. So what does that mean? You're going to have to start with the reference angle, so I probably draw this first. What quadrant? Third. Okay, so here we go. So this is 265. How do we find the reference angle? I'm sorry, say again? No.
I'm sorry, 180.
Oh, so take 265 and subtract 180. What do we get?
85.
Okay, so we got a problem. We have to write the expression tan 65 as the function of acute angle and measure less than 45. Is that less than 45? No. So can we write tan 85? No, so we have to use the co-function. So first of all, we're in quadrant 3. The reference angle is 85. That doesn't help us. It does not fit the description. So what's the co-function going to be? Cotan 5. Now, let's check it though. So I'm going to check, probably to start, tan 265. So tan 265 gives me that. Cotan, 1 divided by tan 5. That same thing. I don't have a cotan button, so I have to use the reciprocal 1 over tan. And I use 5 because Carly said, well, the cofunction is going to be cotan 5. There we go. They're the same exact values. I've got it. Perfect. So look how I walked you right through that. We set it up. First we're in quadrant 3. We find the reference angle does not fit the description, so you're going to have to use the cofunction. They have not approached a problem on the Regents exam yet where you had to do this in order to solve an equation. I could see it happening now. Just FYI. Okay, let's look at these. We should be able to whip these off without even writing them down. Cosine 10 is going to be the same as sine of what? Beautiful. I didn't put the degrees on, so forgive me. Tan of 50 should be what? Cotan 40. Nice. Sine of 90 minus theta should be what? Cosine of theta. Cosecant pi over 3. Not sine. You were right when you started. Secant. This is 60, this is 30. 60 and 30 make 90. Cosecant and secant are cofunctions. All right, so here's something that's very interesting. Why don't you write this down, and I kind of just step by step, so I want to walk you through it. So I want you to solve sine theta equals sine of 90 minus theta. Notice, not 90 minus theta, it's pi over 2 minus theta. So I want to walk you through this because this is a little funky. I can see this as a 2 or 4 point question. So the first thing you have to realize is you're working in radian measurement, and this is just 90 minus theta, so you know you're working with cofunctions. You have sine theta, you've got sine of 90 minus theta, so it's like, what's this all about? Well, this sine 90 minus theta is just what? That's just cosine. You know that. Or you've got to recognize that this is just your cosine function. Sine theta equals cosine 90 minus theta. Cosine theta equals sine 90 minus theta. So now I've got this scenario. I'm going to divide both sides by cosine. Sine over cosine is tan. And I have to solve. Second tan 1 gives me 45 degrees. And it's done. The only thing I didn't do is that I didn't find the answer for the third part. So that would be 5 pi over 4. So another solving. And I think, ladies and gentlemen, that's it. So do you have that all written down? Okay. Wait.
Can you scroll down?
Yes, I can. 5 pi over 4. So I just took 180, added 45 degrees to get to quadrant 3. Fine. So there's your homework assignment. It's a good time.